Hello everyone, so this is mathematics paper 1. I'll be making videos for each of the topics which are here, and these topics are meant to prepare you for your exams. So I'll be getting examination questions from 2016 up to 2024. Those are the questions that I'll be using as the examples. And what you are supposed to do is, after you watch the video, you see how the questions are solved. Try to go and solve them on your own, and then come back to the video to see if you solved them right. And then I'm going to also upload the solutions on my Google Drive, so that you don't have to watch the video every time for you to check the solutions. You can still go and check them, and then the video will just be helping you for explanation purpose. Yeah, so here are the topics for paper 1. So we have got indices, factorization, simplifying algebraic expressions, quadratic equations. Of course, they are not using the bus formula, but if you want, you can use the bus formula. Then we have got sets, then we have got arithmetics, then arithmetic progression, probability, vectors, matrices, geometry, coordinate geometry, circle theorems, similar solids, trigonometry, variations, computer mathematics, mensuration. On this topic, we are not going to do everything like the first round. What those things are for paper 2. So the part for paper 1, it will be the sector. So functions now. Then you have got bearings, linear programming. Of course, also for linear programming, it's not every single part, but there is a part specifically for paper 1. So that's what we will do. But the other part for paper 2 will be done in the videos for paper 2. Because I want to make only for paper 1, I'll also make for paper 2. Okay, and then we also have calculus. You will know the part that comes in paper 1. Then graphs of parabola, time graphs, approximations, and the transformations. So once you know all of these topics which are here, it means you are very much prepared for paper 1. It means distinction is calling you. Okay, so I'll be with you throughout the entire journey and help you with each of these topics, so that when the time for you to write the exam comes, the exam will be very much easy for you. So I will start with the first topic, which is the indices. So questions under indices, they are asked mostly based on 3 parts. The first thing that they ask about is has to do with the square roots, cube roots, fourth roots, fifth roots, etc. So all of these questions that you are seeing here, they are just based on this concept. Then apart from this, they can ask questions also which requires direct application of the laws of indices. So I have the examination questions also for that part. I will make another video also for that. Then they can also ask questions relating to exponential equations. I'll also make a video for that, so that when you watch these 3 videos, you are prepared for this topic, indices. So even grade 10, 11, they can still watch this, because preparation for the exam is not only done in grade 12, but it starts from grade 10. Okay, so now before I explain, or before I answer the questions which are here, I want to give you the basic concept behind this part that will be helping you answer every single question like this. So let me use a separate paper that I will explain those concepts. So as you can see here, I've broken it down. I've got the square root here, cube root, fourth root, and the fifth root. So square root, what does the square root means? If they want you to find the square root of a number, they mean you should look for a number whereby when you multiply by itself, it will give you that particular number. For example, let's say you are dealing with the square root of a. So it means that a number when you multiply by itself gives you a. So in this case, I'll use the example of square root of 4. So a number whereby if I multiply by itself gives me 4 is 2. So this tells me that the square root of 4 is 2. So that is what they mean when they tell you to find a square root. Then we have got cube root. So cube root, what happens is you are going to have a 3 there. So for square root you have got nothing there, but for cube root you have got a 3 there. So cube root of a, it means that a number when you multiply by itself for 3 times it gives you a. So let's take for instance, we find the cube root of 8. So cube root of 8, it means that a number when we multiply by itself for 3 times is going to give us 8. So that number is 2, because when I do 2 times 2 times 2 3 times, 2 times 2 4 times 2 is 8. So this tells me that the cube root of 8 is 2. So that's how we deal with the cube root. And then now we move on to fourth root. So fourth root and the cube root is the same idea, only that here where you have got a 3, you are going to have a 4 from the word fourth. So fourth root of a, it means a number when you multiply by itself for 4 times, it will give you a. So let's take for instance, we find the fourth root of 16. So it means that we are looking for a number when we multiply by itself 4 times, it will give us 16. So that number is also 2. So when you do 2 times 2 times 2 times 2 4 times, it will give you 16. So this thing will be equal to 16. So this helps you now to understand that the fourth root of 16 is 2. Now let's go now to the idea of fifth root. So for fifth root, you are just going to have 5 there. So fifth root of a number when you multiply by itself 5 times gives you a. So let's use 32 as an example. We find it's the fifth root. So meaning that a number when we multiply by itself 5 times, it will give us 32. So that number is still 2. 2 times 2 times 2 times 2 5 times, the answer is 32. So when we do 2 times 2, the answer is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2, that is 32. So this tells me that the fifth root of 32 is 2. Yes, so this is how we deal with these things. So that is the idea behind the square root, cube root, fourth root, and fifth root. Now you know. So after you have known that, let me also introduce you to something. So you have to know that when we write x to the power half, this is the same as writing square root of x. So anything raised to the power half, it means a square root. So if I say e.g. you are going to have 4 to the power half, this is the same as the square root of 4, which is equal to 2. So you have to know that, because sometimes they just ask like this. You have to know that that means the square root of x. Or when they ask 4 to the power 1 over 2, that is the same as the square root of 4, which is 2 as your answer. Okay, then now what about if you have got x to the power 1 over 3? So x to the power 1 over 3, you have to know that it means the cube root of x. Yes. So x to the power 1 over 3 is the same as cube root of x. So how can they ask you that? So they can ask you, I'll use these same examples which are here. So they can ask you to say you have got 80 to the power 1 over 3. So this one I've said that you have to know that it is the same as the cube root of 8. So this is the same as the cube root. So 3 here and then 8 here. So cube root of 8, we have already found it there. We have found that it is 2. So your answer will be 2. And then now, also what about x to the power 1 over 4? So x to the power 1 over 4, this one means the fourth root. of x. So for example, we can say 16 to the power 1 over 4. So this one, 16 to the power 1 over 4, we have said that it means the fourth root. So fourth root of 16. So 4 there and then 16. And the fourth root of 16 is 2. So that is your answer. Also fifth root. So x to the power 1 over 5. So x to the power 1 over 5, you have to know that it is the same as fifth root of x. So e.g. we can say 32 to the power 1 over 5. So this one is the same as writing fifth root of 32, and the fifth root of 32 is 2. Yes, so the purpose of giving you this is so that you just have an idea, but bear in mind that in the exam it's not that every answer will be 2. So these are just examples. Okay, so from here it means that I've given you the basic concept behind the square roots, cube roots, fourth roots, and the fifth roots. And then also questions on here, they are usually combined with the idea of negative index. So you have to know that negative index represents the reciprocal of a quantity. So let me write here, say negative index. So I said that it represents the reciprocal of a quantity. So what do we mean when we say reciprocal? So reciprocal, you have to know that it is the opposite. So let's say you have got 2 here. When you have got a number like this, just know that it is always over 1. Even if we don't show that 1, is always over 1. So this is the same as 2 over 1. So reciprocal will be equal to, we do the opposite now. Numerator becomes the denominator and the denominator becomes numerator. So you are going to have 1 over 2 as the reciprocal. So whenever you have seen something with a negative power, just know that it represents the reciprocal of that particular thing. So let's say, for example, you have got 3 to the power negative 2. So this one, 3 to the power negative 2, you have to know that here is like you have got over 1 here. So you have got over 1. So it will be a reciprocal. So what happens now is that the reciprocal, you are going to have 1 over 3 to the power 2. So 3 to the power 2 was on top and then it will come down. So when it comes down now here, what happens to the negative? It changes to be positive. So 1 over 3 squared. So this one, 3 to the power negative 2 is the same as writing 1 over 3 squared. And 1 over 3 squared, you can further evaluate it. You can say 1 over 3 squared, the answer is 9, because that is 3 times 3. Yes, so that is about that. Okay, so I hope we are clear on this one. Now what about if you have got another one? Let's say you have got a over b and then to the power negative 3. So this one, as usual, is like you have got over 1 here. And then you can deal with the reciprocal. So 1 will go on top. So we are going to have 1 over, and then these things will come down now, but the power now will stop having a negative, but it will bear a positive. So we are going to have a over b to the power 3. And you know that you are going to have 1 over this 3. It means it's for everything. It's for a and it's also for b. So we are going to have 1 over a to the power 3 over b to the power 3. And then to further evaluate that, so this line represents division. So this is the same as 1 divided by a to the power 3 over b to the power 3. And division changes to multiplication. So you are going to have 1 times. Now when it changes to multiplication, these two things, they swap. So b to the power 3 goes on top, a to the power 3 comes down. So you are going to have b to the power 3 over a to the power 3. And then here you balance it with 1 and then you do direct multiplication. So your final answer is going to be b to the power 3 over a to the power 3. Okay, 1 times b to the power 3, the answer is b to the power 3. 1 times a to the power 3, the answer is a to the power 3. So this is the basic introduction. So with this basic introduction, then you are prepared to go and answer those questions with me. Okay, so let's go to the questions now. So these questions will now be simple for us. So it's saying evaluate the following. So we have got 8 to the power 2 over 3, and this one is for 2016 internal. So I'm going to put solutions here. So then make sure that you are able to see everything that I'm doing so that you understand properly. So I'll put solutions here. Solutions. So here the first one, we have got question 1, which is saying 8 to the power 2 over 3. And remember, I said that, so this one brings us to this idea. The idea of here, saying x to the power 1 over 2 is the same as square root, x to the power 1 over 3 is the same as cube root. But only that here you are not going to have, you are not having 1 now there, you are having a number. So what you do, if there is another number here other than 1, it still means cube root, but this 2 has to be used as well. So what you do, if it comes like this, you are going to introduce the symbol for square root like this, and then this 8 you put it inside like that. This 3 you put it there so that it should represent a cube root. Always the number which is down goes there. Whether it is a 4, it is a 5, you put it there. And then you put everything inside the brackets. And then this 2 which is on top, always it comes there like that. So this one, writing this is the same as writing that. So don't forget this. So from here you can deal with what is inside there first. So here inside you can see that you have got the cube root of 8. So the cube root of 8 is 2. So everything inside this one is representing a 2. So you are going to have a 2. Now this thing, they also are raised to the power that 2. So it's like you have got 2 to the power 2. And 2 to the power 2, you know that the answer is 4. Because this one means 2 times 2, which is equal to 4. So the final answer is 4. So that's how we deal with a question like this. Okay, so remember, if you still didn't understand a certain thing after I do it here like this, you still have the right to contact me so that I can schedule an online appointment where I can teach you this again. But I hope I'm clear enough whilst I'm making these videos, so that even without calling me, you are still able to understand. Okay, so this is for question 1. Let's go to question 2. So question 2 now, we have got 27 to the power 2 over 3. So this is the same concept with question 1. So here, what we would do now is, we are going to introduce the square root symbol. And then this 27, I said you put it inside here, so 27. And then this 3 which is down, that's what you put there, so 3. Then open bracket, close. And then this 2 which is on top always goes there, 2. So here now, we will look for the cube root of 27. Meaning that a number, when we multiply by itself 3 times, gives us 27. So the answer is 3. Because when we do 3 times 3 is 9, 9 times 3 is 27. So everything inside here is representing 3. So we are going to have 3 here. And then this 2 will come there. So this is the same as 3 squared. And you know that 3 squared is equal to 3 times 3. And this one gives us 9. So the final answer is 9. Yes. So don't fail any question like this. And remember, this one was from the exam also 2018 GCE. Then let's go to question 3. Question 3 now, we have got something like this. 8 over 27. all of these things have been raised to the power 2 over 3. And there is no any negative involved in there, so we cannot apply the concept of negative index. So when it is like this, you have to know that this thing 2 over 3 is for everything. It is both for 80 and 27. So we are going to separate them. So we'll say 80 to the power 2 over 3, and then also over this 27 will also go with that. So 27 to the power 2 over 3. So which will be equal to, so when you do that now, you are going to deal with this alone. So when you look at this one, this is the same as question 1. So this is like question 1. And what is down here is like question 2. So it's like these people. And remember, this one was for 2024 GCE. So it's like when they brought 2024 GCE, they combined the question which came in 2016 and the question which came in 2018. They combined them together. So these examiners, they are fine. So we have got 8 to the power 2 over 3. So this one, we said that you write the symbol for square root. This 3 goes there, and then this 8 comes inside, and then that 2 goes there outside. Then over the same thing, square root symbol, 27 will come here, 27, then brackets here, and then we say that this 3 which is down goes there, and then this 2 goes there. So we deal with what is inside. So we say this is the same as cube root of 8. So cube root of 8, we have found it is 2, and then it will be 2 squared. Yeah, and then over cube root of 27, we have found it is 3. So it will be 3 squared. So we are going to have 2 squared is 4. Over 3 squared is 9. So this is your answer, because there is no number which can go into 4 and 9 without leaving a remainder. So that is question 4. Okay, so question 3. So that's how you solve any question like this. So from there, we can go to question 4. So for question 4 now, it has got a negative power. So this is where we apply the concept of a negative index. So remember, I've said that a negative index just represents the reciprocal of a quantity. So question 4, what you have to know is that it came in 2020 GCE. So I'll write here question 4. So question 4, you have got 64 over 125, then raised to the power negative 1 over 3. So let's deal with the idea of a negative power. We write the reciprocal of this. Remember, I told you that this is the same as saying over 1. So you just have to swap them. 1 go on top, this one comes down, and then it will come with a positive power now. So this is the same as saying over 1. Then you are going to swap them. This one comes down, and then 1 goes on top. So you are going to have 1, then over 64 over, so you have got 64 over 125, and these things, they have been raised to the power 1 over 3. Now the rule is that when you move it from the top to the bottom, the negative has to disappear. It is supposed to bear a positive power. Okay, so having done that, now next we proceed. So the way we are going to proceed here now is, you have to deal with what is down here. So 1 over 3 is on both 64 and 125, like I told you. So this one will just be coming. So you are going to have 1 and then over. Now here you are going to have 64 to the power 1 over 3, then over 125 to the power 1 over 3. Now this one, you bring it like this. You are going to have 1 then over. I said that 64 to the power 1 over 3, this one is the same as saying cube root. If there is a 1 here and there's a 3 here, this is the same as saying cube root of this. So this is the same as cube root of 64 and then over. This is also the same as cube root of 125. So after you have dealt with that, now next thing, so this one is two following, so we are going to have 1 over, you have to find the cube root of 64. So remember, I told you that the cube root of 64, it is a number whereby when you multiply by itself for 3 times, it gives you 64. So the cube root of 64, you have to know that it is 4. So here you are going to replace with 4. Then since here there was a 1, so you have got nothing there, so you just write 4 like that. And then over here, cube root of 125. The cube root of 125, you have to know that it is 5, because when you multiply 5 by itself 3 times, the answer that you're going to get is 125. So where there is a cube root of 125, you're going to put 5. Having done that, you can deal with the fraction. So this one, it means division. So this is the same as 1 divided by, of course you can go direct, but here I'm showing everything because there are different people who will be watching. Some of them, they might not get it when I just do everything just direct. So that's why I'm taking my time to explain everything in detail. Yeah, so like this, 1 divided by, and then 4 over 5. And then this is the same as saying 1 division changes to multiplication, so times, and then these two they swap. So 5 on top, and then 4 down. So 1 times all of these things, it is just the same thing. So your final answer is going to be 5 over 4. You have found that. That is your solution. So this is how you deal with any question like this. Okay, so this was question 4. So let's proceed now to question 5. So I have to flip my page now for question 5 because this page is depleted. So question 5. So for question 5 now, I'll write there question 5. So question 5, this is for 2017 internal. So it's saying 81 over 16 to the power negative 1 over 4 plus 81 over 16 to the power 0. Yeah, it's an interesting question, this one. So for this question 5, how we are going to solve it, we will apply the concept of a negative index or a negative power, and we'll also apply everything that we applied on the other questions. And then we have also been introduced to another concept, and that is the concept which has to do with the 0, a quantity raised to the power 0. So you have to know that any quantity raised to the power 0 is the same as 1. So let me write that question. So we have got 81 over 16 here, then raised to the power negative 1 over 4. Yeah, then plus we have got 81 over 16, then raised to the power 0. So let's deal with this one which is on our left side first. So for this one which is on our left side, we can deal with the negative power first. So you just know that here it is like over 1. Then here I already mentioned, say 1 go on top, and then this one comes down, and then its power will bear positive now when it comes down. So we are going to have 1 over, then we'll have 81 over 16, and then now to the power 1 over 4, which is positive, and then plus anything raised to the power 0 is the same as 1. So 81 over 16 to the power 0, this is 1. So we say plus 1. Replace everything with 1. Let's deal with this one now. So this one, the way it is, you can even finish it on your own now, if you have understood question 4. But I'm going to finish it. So next thing, we have got 1. So the other thing that you can do here, this division, you can deal with it in advance if you want. But let me not confuse you. So I'll bring 1 here, and then over. So this 1 over 4, it is representing both 81 and 16. So we are going to have 81 raised to the power 1 over 4, then over 16 also raised to the power 1 over 4. Okay, so having done that now, the next thing we have to do is this one will be coming like that, so 1 over, and then now we are going to have 81 raised to the power 1 over 4. I said that this is the same as the fourth root of this one, which is here. So this is the same as the fourth root, so 4 here, which is here, and then 81 inside, and then this one has to come there, but since it is a 1, it doesn't mean anything, so don't put it. Then over here, this is also the fourth root of 16. So you bring the symbol for square root here, you write your 16 inside, you write your 4 there, and then this one has to be outside, but since it's a 1, it doesn't mean anything, so you leave it. And then plus this one, don't forget it. It might make your answer to be wrong. Okay, so here it means that the next thing that we have to do, we need to find the fourth root of 81. So fourth root of 81, it means a number when we multiply by itself 4 times it gives us 81. So that number is 3. So when you do 3 times 3, 9. 9 times 3, 27. 27 times 3, 81. So 4 times it will give you 81. So here we are going to replace with 3. So it's like now we are going to have 1 over everything here is replaced with 3. And then here also we also have another over, this over, which is here, fourth root of 16. Number when we multiply by itself 4 times give us 16. So that one is very easy. It's 2. So 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. So everything here will be replaced with 2. And then plus this one, 1. So let's deal with this one first. So this is the same as 1. Let me up now. If I go direct, it's okay, because I've solved a lot of questions where I've been showing everything. So you are already familiar with what we do. So you can go direct to multiplication. So it will be 1 times. When you go direct to multiplication, 2 comes on top, over 3 comes down, then plus 1. So here 1 times 2 over 3, the answer is 2 over 3, and then plus 1, so plus 1. So here if you want, you can look for common denominator, but the easy way is to do this. You can do 3 times 1, and then the answer you're going to have plus 2, and then the denominator remains the same. So this one will be 3 times 1, the answer is 3. So these 2 will come the way it is. So you have got 2 plus 3 times 1, which is 3, and then over the denominator remains the same. So you are going to have 2 plus 3 is 5 over 3. So if you want to do it the grade 2 way, you can do like this. So you have got 2 over 3 plus 1. You can balance with 1, and then common denominator 3. 3 into 3, 1. 1 times 2 is 2. Plus 1 into 3, 3. 3 times 1, 3. Then when you add there, you have got 5, and then over 3. So it's giving you the same answer. So this one is quick. So this is your final answer for question 5. Okay, after question 5, let's proceed now to question 6. So we are left with question 6 and question 7. So for question 6 and question 7, we have been given so this one for question 6, it came in 2019. Question 7, it came in 2022. So to do that, I'll write question 6 first. So question 6. So for question 6, we have let me check it again. Fourth root of 81 raised to the power 3. So we have got fourth root of 81, then raised to the power 3. So to do that, we deal with what is inside. This is very simple. It's like they have just given you only this. Where is that? We solved something. It's like they have just given you only this and then tell you to find the answer. So it's very simple. So what you do, you deal with what is inside. Fourth root of 81. So we have already said that the number when multiplied by itself 4 times gives you 81 is 3. So you replace all of this with 3. Then it is raised to the power 3. So this is the same as 3 times 3 times 3. So 3 times 3, 9. 9 times 3, 27. So your final answer is 27 there. Question 7. So question 7 now, it came in 2022 internal. This is 3 over 2 raised to the power negative 2. So 3 over 2 raised to the power negative 2. So this one you can deal with a negative power, a negative index. So you have got over 1 here. So 1 goes on top, this one comes down, then it will bear a positive power. So you are going to have 1 over 3 over 2, then squared, like that. So you're going to have 1 over, this 2 is both on 3 and on 2. So you're going to have 3 squared over 2 squared. So this one now will be equal to 1 over 3 squared is 9 over 2 squared is 4. So this one is the same as 1 times 4 over 9. Remember, I've just done it direct. So this one they swap. So your final answer will be 4 over 9. You are done. So thank you very much for watching. So that is how we deal with indices that involve square roots, cube roots, fourth roots, fifth roots, and negative power. This is Mr. Puri. Thanks for watching.